Hello everyone, I am Gurmeet Singh. Welcome to CREATA classes and also welcome to the third lecture in the probability series. In this lecture, we will cover the NCERT example questions. We have divided the NCERT example question into two parts. This is the first part and we will also take the second part. Apart from that, we are having the next three video on exercise 15.1. And all the questions we will do using the power of visualization, that is using the graphics and the animation. Hope you like our new way of teaching. One important thing, we will not superficially do the question, we will go deep into the question and we will also explore the alternate ways through which we can solve the same question. That is really important. Your understanding of the question and also going deep into the question. So without taking any further time, let's take down our first question. Our first question is, a bag contains a red ball, a blue ball and a yellow ball. All the balls being of the same size. Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out the first yellow ball, second red ball and third blue ball? This question is having three parts. Before taking down the question, we have two strict rules that we will follow and I want you to also follow these two rules. The first rule is that do not directly jump to the formula. We have a normal tendency that we look the question and we try to match it with the formula. So this is the first rule, we will not directly jump to the formula. The second rule is that we have to visualize the question. Before jumping to the formula, we have to visualize the question. Only once we visualize the question, we will try to link it with the formula and we will see how to approach the question. So, two rules. First, do not jump to the formula. The second rule, to visualize the question. Okay? So, let's approach this question. Firstly, let's visualize the question. In this question, a bag is given. This is a bag. And the bag contains a red ball, a blue ball and yellow ball. It means that it is having three balls, red, blue and yellow. Kritika, she has to take one ball out of the bag and we are having three questions, whether the ball that Kritika takes out is yellow and red and blue, the probability of three different colors of ball. So we have visualized the question. Now let's have the formula of probability. This is the formula of probability. In the denominator, it is given number of all possible outcomes. Here, what are the various possible outcomes can be there? Suppose Kritika puts the hand into the bag and takes out yellow ball. So this is the first possibility. Yes, she can take the yellow ball out of the bag. Or the other possibility is that the ball can be of red color, that is red ball. Or the third possibility is that the ball can be of blue color, that is blue color ball. So we have total three possibilities. So in the denominator it will be 3. That is number of all possible outcomes in this case or in this experiment is 3. Either yellow ball or red ball or blue ball. So in the denominator we got 3. Let's check what it will be there in the numerator. In the first case it is given yellow ball, means we have to calculate the probability of getting the yellow ball out of the bag. So in the numerator it will be number of outcome favorable to our event E. Here the event is yellow ball. So out of the three scenarios, our scenario yellow ball is only 1. So on the numerator it will be yellow ball, that is 1. So our answer for the first case is 1 by 3. That is 33.3%. If Kritika puts the hand into the bag and the possibility or the probability of taking the yellow ball out is 1 by 3 or 33.3%. Got it? Similarly, if we take the second case, that is red ball, here the denominator will remain the same, that is number of all possible outcome of this experiment is 3. That is yellow ball, red ball and blue ball. Only the numerator will change. Here the numerator will change to red ball. that is number of outcome favorable to our event. Here the event is taking the red ball out, that is 1. So again our answer is 1 by 3, that is 33.3%. Similarly, in the third case, that is blue ball, the denominator will remain the same. Only the numerator will change. That is, now we will have the blue ball in the numerator. That is again 1 by 3. So our answer is 33.3% for all the 3 cases. Got it? So we got the answer. Just wait, we got the answer, but our learning is still pending. We have done some observation in the previous lecture. Let's try to apply those observations in this question. Our aim is not get the answer. Our aim is to understand the question, understand the concept of probability. We will try to link all the concept, all the observation that we have done in the previous lecture, and try to link with the previous question so that your understanding about the probability can be enhanced. Okay? So if you see this experiment that is taking the ball out of the bag, we are having 3 events, that is yellow ball, red ball and blue ball. And we have done the observation in the previous lecture, that is if we add all the probabilities of the experiment, it should comes out to be 1. So if we add the probability of yellow ball plus probability of red ball plus probability of blue ball, we get 1 by 3 plus 1 by 3 plus 1 by 3, it is 1. Okay, so we got our observation, that is if we add the probability, it should be 1. That is 33.3%, 33.3% plus 33.3%. It comes out to be 100%. So our concept is matching here. One more concept. Suppose we have a question out of this experiment. What is the probability of not getting the yellow ball out of the bag? That is P Y bar. Here bar is symbolizing that not yellow ball. What is the probability of not getting the yellow ball out of the bag? Are you getting this question? What is the probability of not getting the yellow ball out of the bag? That is PE bar, P yellow bar. That is equal to 1 minus PE, that is 1 minus probability of happening of the event, which is 1 minus 1 by 3. The same we have just calculated. So we got our answer as 2 by 3. That is the probability of not getting the yellow ball out of the bag is 2 by 3. Let's try to get the same answer through the other method. That is, what is the probability of not getting the yellow ball out of the bag? It will be getting the red ball or getting the blue ball. If we get the red ball or the blue ball, it means that it is not the yellow ball. Got it? So what is the probability of getting the red ball? It is 1 by 3. And the probability of blue ball, it is 1 by 3. So the probability of getting red ball or blue ball is 1 by 3 plus 1 by 3, that is 2 by 3. So we again got the answer, that is probability of not getting the yellow ball is 2 by 3. We have already done the answer, just I am adding some of the more concept so that your clarity about the probability can be enhanced. Okay? In the question, we are having only 1 yellow, 1 red and 1 blue ball. Suppose we are having 2 yellow ball, then how our answer will be changed? Suppose we are having 2 yellow ball, then in the denominator we are having total 4 outcome. 2 yellow, 1 red, 1 blue, and on the top if we have to calculate the probability of getting the yellow ball, it will be 2 yellow ball. That is 2 favorable outcome will be there, first yellow ball and the second yellow ball. So our answer will be 2 by 4, that is 1 by 2, 50%. Just trying to add some of the other cases that can be formed out of the question. We have a similar type of question of the different marble case that we will take down afterwards. Okay? Let's move to the next question. Our question is, suppose we throw a die once, what is the probability of getting a number greater than 4? Second part, what is the probability of getting a number less than or equal to 4? Let's try to decode the question by visualizing the question. We will not directly jump to the formula. In this question, we are rolling the die. So what are the various events or the outputs that we can get out of rolling of the die? We can get total 6 events or 6 outputs, that is getting 1, 2, 3, 4, 5 and 6. The question is asking what is the probability of getting a number greater than 4. And in the second part it is asking what is the probability of getting a number less than or equal to 4. In the first part, what are the various numbers which are greater than 4? It is 5 and 6. So the question is asking what is the probability of getting number 5 and 6. And in the second part, the question is saying what is the probability of getting number less than or equal to 4. That is, the question is saying what is the probability of getting 1, 2, 3, 4 when we roll the die. So number less than and equal to 4 are 1, 2, 3, 4. So in the first case, we have to calculate the probability of getting 5 and 6. In the second case, we have to calculate the probability of getting 1, 2, 3 and 4. Now let's take the formula into the picture. This is the formula and let's start with the denominator. What are the number of all possible outcomes? Here we are rolling the die, we are getting total 6 output. So in the denominator, in both of this case, the denominator will be 6. That is, we can either get 1, 2, 3, 4, 5, 6. The total number of outcomes are 6. Firstly, take the first part. In the first part, we have to calculate the probability of getting 5 and 6. So in the numerator, our favorable outcome are 5 and 6. That is 2. 5 and 6, we are having 2 outcomes. So we got 2 in the numerator and 6 in the denominator. We got our answer of first part as 2 by 6, that is 1 by 3. Got it? In the second part, we are having 4 options in the numerator. That is, the favorable outcomes are 1, 2, 3 and 4. So in the numerator it will be 4, denominator we have already calculated as 6, so we got our answer as 4 by 6, that is 2 by 3. Got it? The answer or the approach is very simple. Just we have to decode or visualize the question, what the question framer is actually asking. The wording may be slightly confusing or slightly tricky, but once you are able to visualize the question, decode the question, then the approach or the applying the formula is very, very simple. One more thing, here in this question we can also apply our observation. The observation, that is the addition of all the event, is 1. Here it is slightly tricky. Let's see how we can apply those observations. Here in the first case, we have calculated the probability of getting the number greater than 4, and in the second case we have calculated the probability of getting the number less than 4 or equal to 4. So if we add both the probability, that is 1 by 3 plus 2 by 3, we get 1 by 3 plus 2 by 3, that is 1. So addition of both of this event is 1. Let's observe this. Here we are having 6 event. In the first case, we have calculated the probability of getting 5 and 6. In the second case, we have calculated the probability of 1, 2, 3, 4. It means we have covered all the events. 5, 6 in the first case, 1, 2, 3, 4 in the second case. So if we add the probability of both of these events, then it should be 1. Why? Because we have covered all the events. If we have missed one event, then the outcome will not be 1. Let's see what I am actually talking about. This is important concept and you should know it. This will be really helpful, believe me. Suppose in the second case, we have to calculate what is the probability of getting number less than 4. Less than 4, it is 1, 2, 3. And in the first case, we have covered 5, 6. In the second case, now we have covered 1, 2, 3. Number 4 is missing. In this case, the addition of probability will not be equal to 1. In the first case, it is 1 by 3. In the second case, the new one, it will be 3 by 6. That is 1 by 2. So if we add 1 by 2 plus 1 by 3, that is probability of both the event, we get 5 by 6. Here this 5 by 6 is not 1. Why? Because we have missed the number 4. The addition 1 will come when we have added the probability of all the possible outcomes. Here number 4 is missing, so we will not get the addition as number 1. Suppose we have to calculate the probability of getting the number 4. It will be 1 by 6. Okay, 4 in the numerator, the number 4 in the numerator, that is only 1, and number 6 in the denominator, that is 1 by 6. That will be 1 by 6. Okay, if we add 1 by 2 plus 1 by 3 plus 1 by 6, that is we are adding the probability of all the possible event. Okay, we will get the number 1. The sum, that is number 1, the addition number 1 will come when we add the probability of all the event. This is very important in the question. The question framer may trick you, he may miss some of the events, or you are not able to calculate all the possible event. Then your addition, if you take the addition as 1, then your answer will be wrong. You have to calculate all the event and you have to be aware of what the question framer is actually asking in the question. Okay. So we are taking some extra time in the question, but believe me, this will be really worth for you. Your basic foundation of probability will be clear and you will be able to solve all the questions of the probability. Let's move to the next question. The question is, two players, Sangeeta and Reshma, plays a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning this match? Just pause the video and try to solve this question on your own. Then I will tell you how to solve this question. This is very simple question. Try to visualize the question and apply the simple formula of the observation that we have done in the previous lecture. Okay. Two players are given, Sangeeta and Reshma, and they are playing a tennis match. And the probability of winning Sangeeta is given as 0.62. We have to calculate the probability of Reshma winning the match. Here if we apply the observation, we are getting two events, that is probability of winning of Reshma and probability of winning of Sangeeta. So can we say the probability of winning Reshma plus the probability of winning Sangeeta is equal to 1? Yes, we can say. We are having two events and these are the only two events we can get. Either the Sangeeta will win or the Reshma will win. So we can say the addition of both the event will be equal to 1. That is, probability of winning of Sangeeta plus probability of winning of Reshma is equal to 1. And one case is given, that is probability of winning of Sangeeta is given as 0.62. So directly we will use the formula and we will put the value. We got our answer as 0.38. That is, the probability of Reshma winning the game is 0.38. That is 38%. Okay, the probability of winning of Sangeeta is 62% and probability of winning of Reshma is 38%. Or in other words, we can also say the probability of losing of Reshma is 62% and the probability of losing of Sangeeta is 38%. You have to play with these numbers. You have to actually understand the question. Once you are able to actually understand the question, you will be able to solve all the questions. Let's move to the next question. The question is, Sangeeta and Hamida are friends. What is the probability that both will have, first case, the different birthdays, second, the same birthday? In the question it is given, we have to ignore the leap year, means we have to take the number of days of the year as 365. Take some time, pause the video and try to think what the answer can be or how to visualize the question. That is important. Just try to think what the question is asking, what the question framer is thinking, and what are the various cases that can be formed. Just pause the video, think and come back. Okay, welcome back. Let's try to visualize the question. In the question, two friends are given, Savita and Hamida. And in the question, we have to find the probability of common birthday and different birthday. In the calendar year, this is the calendar, we are having 365 days because we are not considering the leap year. In the calendar, we are having 365 days. Suppose Savita is having birthday on 1st of January or any of the day, suppose 3rd of March, any days you can take. Suppose Savita is having the birthday on 1st of January. Then on which day the Hamida can have birthday? She can have birthday on all the 365 days. She can have the birthday on 1st of January, that is on the same day, or she can have the birthday on rest of the 364 days. Okay? First day we have excluded, that is she can have the birthday on first. If the birthday is not on the same day, then she can have the birthday on rest of the 364 days. So this is the catch. Based on this information, we will solve this question. In the first case, it is given both have different birthday. It means that Savita is having the birthday on any one day. Suppose in this case we can take 1st of January, but you can take any of the day. And Hamida is having birthday on rest of the 364 days. Why? Because birthday is not matching, both are not having the same day birthday. Now we will use the formula. This is the formula. We will start with the denominator. What are the total possible outcomes? The total possible outcomes are 365 days. These are the total 365 days of a calendar year that will come in the denominator. And what will come in the numerator? In the numerator, it will be 364 days in which Hamida can have the birthday. In the question, we have to find the probability that both will have different birthday. So the different birthday case are 364 days. In the bottom, the total is 365 days. That is total all the possible case. In the numerator, the favorable outcome in which they can have different birthday are 364. Got it? So our answer for the first case will be 364 upon 365. In the second case, it is given the same birthday date. Let's try to solve this. In the denominator, it will be 365 outcomes of the experiment. In the numerator, what are the cases in which they are having the same birthday? Suppose Savita is having the birthday on 1st of January. Then if Hamida also have to have the birthday on the same day, then it will be 1st of January. That is, both are having the birthday on same date. So the number of cases is only 1. Here we have taken 1st of January. You can take 3rd of March or any day or any date. The case will remain 1. Suppose both are having birthday on 3rd of March. Then the total favorable case will only be 1. That is the day in which both are having the same birthday. That will be only one day. So our answer will be 1 in the numerator and 365 in the denominator. That is total possible case. So our answer is 1 upon 365. Here we have also used our observation formula and calculated the second case. That is, the probability of different birthday plus probability of same birthday will be equal to 1. The first case we have calculated as 364 upon 365. So the second case we would have easily calculated as 1 minus 364 upon 365, that is 1 upon 365. So we have seen the two approach to solve the same question. And initially the question is looking slightly tricky, but once you are able to visualize the question, decode the question became very simple. Let's move to next question. There are 40 students in class 10 of a school, of whom 25 are girls and 15 are boys. The class teacher has to select one student as a class representative. She writes the name of each student on a separate card, the cards being identical. Then she put cards in a bag and stir them thoroughly. She then draw one card from the bag. What is the probability that the name written on the card is the name of first case a girl, second case a boy? Very simple question. Pause the video and try to solve the question. Welcome back. In the question, 25 girls are given and 15 boys are given. So the total number of students in the class is 40, 25 plus 15, which is also given. And the class teacher has to select one class representative. She has put all the names of the students on the card, and one card she will pick up. We have to calculate what is the probability that the card she pick up will have the name of the girl, and in the second case the name of a boy. So this is the scenario. Let's use the formula. We will start with the denominator, the total possible outcome of the class. We are having 40 students in the class, so in the denominator it will be 40. That is 25 girls and 15 boys. Let's take the first part. In the first part, what is the probability that it is a girl? So what are the favorable possible outcomes of the girl? It is 25 girls. So in the numerator it will be 25 girls. In the denominator it will be 40 students. So in the first case our answer is 25 by 40, that is 5 by 8. Got it? And in the second case, what is the probability it is a boy? We are having 15 boys, so our favorable outcome in the numerator will be 15 boys. So our answer is 15 over 40, that is 3 by 8. Okay. So we got 5 by 8 as probability of girls and 3 by 8 as the probability of the boys. Here we are using the graphics to show you how easily we can solve the question of probability if we can visualize the question. The same you have to do in the examination. Firstly, you have to visualize the question, then try to solve the question. In the numerator, we have put all the girls and all the boys. In the denominator, the total number of students of the class. So students, that's it for this video. Hope you have enjoyed our unique way of teaching. The rest of the NCERT example question we will take down in the next lecture. This is the probability series, and for rest of the lecture, refer the link in the description. Thank you very much. Have a great day and bye for now. Meet you in the next lecture. Bye bye.